Hello, I'm Anna Mackay, and this video is on finding the mean or mu or finding sigma or the standard deviation. So let me give you a tip on this one. Whenever you come across a question where you're asked to find the mean or the standard deviation, chances are you're going to have to use a Z-score, so a standard normal Z-score to help you work that out. So I've got two examples here. The length of steel rods produced by a machine is normally distributed with a standard deviation of 3 millimeters. It is found that 2% of all rods are less than 25 millimeters long, and you're asked to find the mean length of rods produced by the machine. Again, if you're not sure what to do with these types of questions, draw yourself a picture. Do you know, even if you do know what to do in these questions, you should draw yourself a picture. So put on any information that you know. The mean, you don't know, question mark. The standard deviation, you could put it next to the mean there, you do know is 3. What other pieces of information? 2% of all rods are less than 25. So less than, that means off to the left-hand side. Just draw yourself a small little section there. 2%, so 0.02 will be in that area. And the end point then is 25. So that's what we know here. So the tip that I gave you is using a Z-score, writing out what that formula is again. Z is equal to X subtract mu over sigma. So let's plug in what information we've got and see if we can do anything with that. So X is 25 in this case. 25 subtract mean, well, that's the one we don't know, over the standard deviation, we do know that that's 3, equals, a Z-score. So we don't know that yet. So what would that be trying to find? The Z-score of that 25 would tell us how many standard deviations away from the mean 25 is. So if we can convert that to using the distribution, a standard distribution with a mean of 0 and a standard deviation of 1, we can work out the equivalent Z-score for this. So to do that, we're actually going to use inverse normal, where we've got our tail would be on the left, area would be 0.02, but here's where it changes. We've got a standard deviation of 1 and a mean of 0. So if you plug that in, see what score you get. You get what will end up being a Z-score of negative 2.05. So that means 25 is 2.05 standard deviations to the left of the mean. So that's its Z-score. So we can put this now into our formula over here, negative 2.05, and it's just some simple algebraic rearranging to solve for mu. You can take as many or as few steps as you like for this. Oh, we should probably put approximately equal to each time now because we have rounded. We've got negative 6.15, and rearranging for mu, we've got 31.15. Again, you could always check now by using an NCD function and put in with a lower and an upper bound here and see if you get 0.02 using that mean. That's a way of checking. So that was trying to find the mean length. The same concept would be used if you have to find a sigma, but what if you have to find both? So here's one example on that. Makers of a soft drink wish to adjust their production process to reduce some of the random errors. Find the mean and standard deviation such that we've got these two facts. Again, draw yourself a picture. So let's have a think about what we've got there, just drawing a bell curve each time. That below a number, 375, the area or the probability is 0.05 or 5%. So that means off to the left somewhere here, doesn't matter how big that area is, it's 0.05 and the cutoff point is 375. And then this probability statement, that means a randomly chosen soft drink above 385, well, we've got a 10% chance of selecting one of those. So 0.10 here. So we need to find out two z-scores to help us with this. So we'll call it, Z1 and Z2, if we like, Z1 and Z2. So based on what we did last time, you need to use you have to work out your tail. This time's on the left. Again, your area is 0.05. Sigma and mu will be 1 and 0 to work out the z-score equivalent. And what did you get? Minus 1.64. And that's good. Negative, that's what we're expecting on the left. And then for the second one, a z-score, we'll just fill out our inputs here. So the tail this time is to the right, an area of 0.10, again standard deviation of 1 and mean of 0, and your z-score is, I hope you're doing this along with me at home, 1.28. So use the z-score formula to input these. Did I create an extra slide? Yes, I did. So I've got some more room here. So they're the two numbers that we've just worked out. And let's use them with z-scores. So just a refresher, z is equal to x, take mean over sigma. So plugging that in here, our x is 375 for this one. Subtract the mean, which we don't know, over sigma, which we don't know, is equal to the z-score of 1.64. And the second formula, 385, take away the mean, over sigma will be equal to that z-score of 1.28. So we have two unknowns here, but we have two equations, so we should be okay to find them. We need to rearrange that so that we can use the simultaneous equations menu, the equation menu, and solve for a simultaneous equation in your calculator. So you know the format that you need to get that in, usually for x's and y's, but whichever variables. So I'm going to rearrange mine to get mean. Take 1.64 sigma is equal to 375, and this one, the second one, mean plus 1.28 sigma is equal to 385. So our two variables are mu and sigma, and then using graphics calculator, I won't show you that this time around. I'll trust that you know how. Your mean is approximately 380.61 millilitres, and a standard deviation, different type of approximately equal to there, 3.42. Okay, and that's what the question asked us to find. So that's the end of this video, and it's the end of the continuous random variable series. If you liked it, give it a thumbs up and subscribe to the channel. Thank you.